Hi, this is Dr. Shabana, working as an associate professor in the Cobalt Engineering College, Cobalt. Today, I want to discuss about batteries, which is there in the electrochemistry for the engineering and the engineering students for CSE and civil of the Unit 2. In this battery topic, what is a dry cell, nickel cadmium cell, nickel metal hydride cell, lithium ion battery, zinc air cell batteries? It is there in the syllabus. Today we will discuss this type of cells. Before going to the dry cell, this lithium ion battery and the zinc air batteries, first we have to know what is battery, how it will function, and what is the construction of the battery, and what are the actual reactions taken inside the battery. Before going that, a battery means it is an electrochemical cell connected in series and can be used as a source of direct electric current at a constant voltage. Battery means it is an electrochemical cell connected in series and can be used as a source of direct electric current at constant voltage. That means it is a device which converts the chemical energy into electrical energy. That means the chemical energy which is in the active material directly into the electrical energy is a actual definition of the battery. And the battery is a term usually applied to a group of two or more electric cells connected together electrically in series. And I already told you it is commercially an electrochemical cell. Coming to the advantages, why the battery is used. Batteries acts as a portable source for electrical energy. Portable. That means it can be taken to anywhere. The portability of electronic equipments in the form of handsets has been made possible by the batteries. A variety of electronic gadgets have been made more useful and popular with the introduction of rechargeable storage batteries having reliability, better shelf life, and tolerance to service. For all commercial applications, batteries are constructed for the service. For example, batteries for automotives and aircrafts, standby batteries, etc. There are some requirements should be possessed by the battery. That means a battery should function in a better way. Some sort of requirement should be there for the battery to function in a better way. The first and the foremost requirement is it is having the high capacity, which is very small variation of voltage during discharge, and high efficiency is calculated by using a formula energy released on discharge by energy required for the discharge into 100. And high cycle life is required, which is the number of charging and discharging cycles before failure. And long shelf life is required. Tolerance to different service conditions, such as variation in temperature, vibration shocks, etc. Reliability is an important criteria for the requirement of a battery. And we can broadly classify the battery into three categories. Here I mentioned only two, but three types of batteries are there. Primary battery or primary cell, secondary battery, and fuel cells is also there, which I'll discuss later in the next lectures. So batteries are mainly of two types. First one is a primary battery and the secondary battery. What is a primary battery? The primary battery is a cell in which the cell reaction is not reversible. That means it cannot be recharged. It can be used as long as the materials inside the battery are active in their composition. That means once the chemical reaction takes place to release the electrical energy, the cell gets exhausted. And the battery can be used as long as the materials are active in their composition inside the cell. And they are thrown up as well as thrown up as soon as the cell gets exhausted. That means it is a use and throw up process. The best example for this is a dry cell. Dry cell is also known as Lithium cell. And the example for the secondary battery, what is secondary battery? The secondary battery is a cell in which the cell reaction is reversible. That means the cell can be recharged and can be used again and again by recharging the cell. Example, lead storage cell. In the lead storage cell, the EMF depends on the activity of the sulfuric acid used in the car batteries. And another examples of the secondary battery are nickel cadmium battery, which is having the EMF of 1.4 volts and has the long life when compared to that of the other used in the electronic calculators, electronic flash, and cordless electronic shovels, etc. So this is about the brief introduction about the batteries and the types of batteries. Coming to the example of the primary battery, that is a dry cell, we will learn about the construction and the working of the dry cell. See here, this is the structure of the dry cell or the primary cell. I already told you that the cell in which the cell reaction is not reversible. When the reactant have been converted to the product, no electricity is produced and the cell becomes dead and cannot be used after that. These batteries are used as a source of DC power. And these cells are convenient to use and the cost is not much. Dry cell, it is a cell without fluid component. It is not having any fluid component. The anode of the cell is a zinc. That means it is a cylindrical container which is made up of the zinc, which acts as an anode. And the electrolyte consists of ammonium chloride, zinc chloride, and manganese dioxide, to which the starch is added and make it a thick paste, and it is filled in the container. To prevent the leakage. And coming to the cathode, zinc is an anode and electrolyte is, already told you that it is ammonium chloride, zinc chloride and manganese dioxide. To prevent the leakage, we have to make it a thick paste by adding with the starch. And coming to the cathode, it is a graphite rod present inside the cell. It serves as a cathode, which is immersed in the center of the cell. So this is about the construction. And this graphite rod with the brass cap and this rod is placed in the electrolyte in the center of the cell. And the cylinder is sealed at the top with a pitch, and a small hole is provided in it to allow the gases formed by the chemical action to escape. So this is about the complete construction of the primary cell. Coming to the reactions. Whatever the reaction takes place at the electrode, that is at the anode and the cathode. At the anode, I already told you that the oxidation takes place at the anode with the liberation of the electron. So here in the primary cell, the anode is a zinc container. It is made to react with the chloride ion and it is converted into the zinc chloride with the elimination of the loss of the electrons. And that electrons comes towards the cathode and it is made to react with the manganese oxide and the water, and it is converted into Mn2O3 with the formation of the hydroxyl ion. So the overall reaction at the cathode and the anode after the cancellation of each components, two electrons are cancelled. Here zinc plus 2 MnO2 plus water plus chloride ion that gives rise to ZnCl2, Mn2O3 and formation of hydroxyl ion. And this hydroxyl ion which is formed in the overall reaction, it made to react with the ammonium chloride to liberate ammonia. This ammonium chloride, in the ammonium chloride, ammonium ion is there. This formed hydroxyl ion, it is made to react with the ammonium ion and it liberates the ammonia. It generates the ammonia, which is not liberated as a gas, but it immediately reacts with the zinc chloride and forms a complex. And this dry cell is a primary cell since no reaction is reversible by supplying the electricity. So it gives the voltage of about 1.1 volts. Coming to the uses of the dry cell. The dry cell is a cheap, I already told, and it is used in the flashlights, transistor, radios, calculators, watches, and pacemakers. Coming to the limitations of the dry cell. When the current is drawn rapidly, there is a drop in the voltage occurred. And since the electrolyte is acidic, zinc dissolves slowly, even if it is not in use. So these are the limitations of the primary cell. Coming to the next cell, that is the nickel cadmium battery. This nickel cadmium battery is a rechargeable battery, or it is also known as a secondary battery, secondary cell. So this is a construction of the nickel cadmium battery. Here in this, the nickel cadmium battery, it is a rechargeable battery, and it is consists of the metallic cadmium as a negative electrode and nickel oxide hydroxide as a positive electrode. And the potassium hydroxide is used as a electrolyte. The cell reaction during the discharging at the anode and the cathode is, at the anode, which we take the cadmium as a negative electrode, this is made to react with the hydroxyl ion from the electrolyte, because the electrolyte is a KOH, and it converts into the cadmium hydroxide with the liberation of electrons. And at the cathode, the electrodes are nickel oxide hydroxide. It made to react with the water, and whatever the electrons which are liberated at the anode, it combines with that electron, and it is converted into nickel hydroxide with the formation of hydroxyl ion. And the overall reaction during discharging is CD, that is a cadmium, plus nickel oxide hydroxide, plus 2 water molecules, that gives rise to cadmium hydroxide, along with the formation of the nickel hydroxide with the liberation of some sort of energy. During recharge, the reaction goes from right to left. That means the reaction will be reversed. From the above cell reaction, it's clear that the cadmium hydroxide and the nickel hydroxides are deposited at anodes and cathodes respectively. So this can be reversed by the rechargeable. And the output of the voltage of this cell is 1.2 volts. During recharging, I already told the reaction is converted from the right side to right to left. See here, this cadmium hydroxide react with the nickel hydroxide with the liberation of some sort of energy that gives rise to the cadmium, along with the formation of the nickel oxide hydroxide with formation of the water molecule. Here, the advantages of the nickel cadmium battery is the potential of the cadmium anode is below the hydrogen potential. Hence, the cadmium electrode is completely inert to electrolyte. It requires no float current to keep charged. The water consumption and flow charge current are extremely low. That's why it is considered as the portable and rechargeable cell and have the high energy efficiency. And the batteries are suitable to very high rate discharge and low temperature operation. So it has a longer life than lead acid battery. And they have this nickel cadmium battery have long shelf life without any maintenance. As it is having the low maintenance, it can be easily packed like the dry cell since it is smaller and lighter. So these are the advantages of the nickel cadmium cell. And coming to the uses, it is used in portable electronics and toys. And it is also used in the photographic equipments and electronic flash units. It is used in the transistors, cordless electronic gadgets, that is appliances, and is also used in the aircrafts and space satellite power system. And coming to the applications where it is applied, nickel cadmium batteries are used, already told it is used in the aircrafts and diesel engine startings, lightning of trains, emergency power supply, and for many military applications. Coming to the nickel metal hydride cell. It is also the rechargeable battery, which is come under the secondary battery, in which the cathode is a positive electrode, which is similar to that of the nickel cadmium cell, with both using the nickel hydroxide and nickel oxide hydroxide. It is similar to that of the nickel cadmium battery only. And the negative electrode used hydrogen absorbing alloy instead of cadmium. Because in the nickel cadmium battery, the cadmium is used as an anode. Here in this metal hydrides, the name itself indicates it is the hydride metal, hydrated metal will be used. So hydrogen absorbing alloy with having the general formula of AB5. And the higher capacity negative electrode material based on AB2 can also be used. For example, lanthanum pentaniclate and Pi2Ni. Nickel metal hydride cells has an alkaline electrolyte using potassium hydroxide with a 5 molar concentration. Polypropylene is used as a separator between the electrodes. And the electrode reactions are: at anode, the metal hydride react with the hydroxyl ion, which comes from the electrolyte KOH, and it converts into the metal with the formation of the water, liberation of the electron. And this electron, it goes into towards the cathode, and it is made to react with the nickel oxide hydroxide and water molecule and forms nickel oxide hydroxides with the formation of the hydroxyl ion. And the overall net reaction is this one. As a nickel metal hydride battery can have 2 to 3 times the capacity equivalent size to nickel cadmium, and its energy density can approaches that of the lithium ion battery. And the overall voltage will be in the range of 1.4 to 1.6 volts. So this is the structure, or this is the construction of the nickel metal hydride battery. So this is a negative electrode, metal hydride, and this is a positive electrode, which is taken as a nickel oxide hydroxide. So this metal hydride is connected to the negative terminal of the battery, and the nickel oxide hydroxide is connected to the positive terminal of the battery. And whatever the electrons which are liberated here at the negative electrode, it goes into the cathode. And it discharges the electrons like that. It is a charger. In between this, the KOH electrolyte is taken, which H plus ions is consumed by the KOH and forms a water molecule. The cycle continues like this. So coming to the application, the nickel metal hydride battery is currently finding its application in cameras, medical instruments, razor, and mobile phones. Coming to the lithium battery. So this is a construction of the lithium battery. In the lithium battery, the most common lithium ion cell has an anode of carbon and cathode of nickel cobalt oxide. The electrolyte in the lithium ion cell is usually, it's a salt of a mixture of solvents like dimethyl carbonate or diethyl carbonate devised to improve the battery performance. Coming to the lithium cobalt oxide battery, it was the first lithium ion battery to be developed. The cobalt and oxygen bond together to form the layers of octahedral cobalt oxide structure separated by sheets of lithium. In this, the structure allows the cobalt ion to change their valence state between the CO +3 to +4 when charging and discharging. During discharging, the lithium ion flows from anode to cathode through the electrolyte within the battery. And the electrons cannot move through the electrolyte. So flow from the anode to cathode through the outer circuit, causing a current to flow. When the ions and electrons combine at the cathode, when the electrons and ions are combined at the cathode, lithium is deposited. See here, lithium is deposited at the cathode. During charging, so it is about the discharging process. During the charging process, the process will be reversed, with ions and electrons flowing from cathode to anode. When the ions can no longer flow, that means the battery is completely charged. It is full of charging. So this is the overall reaction of the lithium battery. Coming to the last battery, that is a zinc air battery. This is a zinc air battery in which the cell consists of zinc plates which acts as an anode. and a perforated carbon plate treated with water repellent, which acts as a cathode. This is a carbon plate which is having the perforation with water repellents, and it acts as a cathode. And in between these two, the zinc plate and the carbon plate, electrolyte is placed. This electrolyte is KOH, alkaline. The cathode allows contact of oxygen from air. At anode, zinc reacts with the electrolyte, that is with the KOH, OH ions. Because this KOH is get ionized to form the K plus and OH minus, this zinc reacts with the OH minus and forms the zinc oxide along with water. The electron travels with the liberation of electron. That electron is traveled from anode to cathode, where the oxygen of the air accept this electron and form hydroxide ion. So this reaction, the zinc, it is made to react with the OH minus ions from the KOH and form the zinc oxide along with the formation of water and the liberation of electrons. And this electron, it is moved from anode to cathode, where near the cathode, oxygen will be there, where it reacts with the electrons made to react with the oxygen, and the electrons with the water molecule to form the hydroxyl ions. And the overall reaction is zinc plus O2, that gives rise to ZnO along with the energy liberation. And these are electrically non-rechargeable, and it can be recharged mechanically by converting the zinc oxide to zinc. The cell output is 1.65 volts. It is theoretical, but in reality, it is only 1.35 to 1.4 volts as output. And this zinc air battery, it has the property of both the fuel cell and the battery cell. Fuel cell, I already told you in the beginning, the types of battery, there are three types, actually there are three types: primary battery, secondary battery, and the fuel cell. So far I discussed up to about only the primary cell and secondary cell. In the next lecture, I'll discuss about the fuel cell. What is a fuel cell? How many types of fuel cells are there? So coming to the application of the zinc air battery, they are used in the watches, hearing aids, cameras, and also for electrical purpose of vehicles, which is known as electrical propulsion of vehicles. So this is about the battery. In the next lecture, I'll discuss about the fuel cell. Thank you.